I went into it and I can explain.
So let's talk about recursion, a concept in computer science where a function calls itself. Imagine standing between two mirrors, you see reflections within reflections. That's recursion, a process repeating within itself, shrinking towards a solution. But for it to work well, it needs rules to avoid it from looping forever. First, there must be a base case, a specific condition that stops the recursion. Without it, the function could run forever. Second, each recursive call must bring us closer to that base case. This usually means simplifying or reducing the problem in some way. Third, the function must call itself. That's what makes it recursive, solving a big problem by solving smaller versions of it. If any of these are missing, the recursion won't work as intended, and it might never stop.
Oh, it makes sense now. Let's try to apply it to some examples.
Let's look at computing the factorial of a number. The factorial of 5, for instance, is 5 times 4 times 3 times 2 times 1. Here is the recursive code of that function. When a function calls itself, the computer stores that call in memory on something called the call stack. Each new call adds a frame to the stack until the base case is reached. Another example is Sierpinski triangle. We start with one big triangle, then connect the midpoint of each side to form 3 smaller triangles. We ignore the center and repeat the process for each small triangles until we hit our base case.
You know some sorts use recursion too?
Which one?
Merge sort. How to go from to using merge sort. Here's how merge sort works. Merge sort is recursive. It keeps splitting a vector in half until each piece has only one item or is empty. At that point, the pieces are considered already sorted. That's the base case. Once we've reached the smallest pieces, the algorithm starts to build the solution back up. It does this by merging the small sorted vectors back together into larger ones in sorted order. Whether it's best case, average case, or worst case, it'll always be log linear.
Wait, have you guys heard the song On and On?
By who?
By us.
When the function calls itself, that's recursion, but you need a base case because that's where it ends.
Shrinking with each step like mirrors, reflecting, repeating through.
Each call gets closer, solving each piece quick and sweet. No loops, just recursion because it can.
5 calls 4 and 4 calls 3, shrinking the problem easily. It keeps on going till we reach 1.
So now you know recursion, it must call itself and move towards the base case, and that's how it's done. Now we give thanks to Berea College and Dr. Jen Pierce for founding the department and writing runestone so we can learn about recursion. Thank you for watching.
Galina,
Aro.
Dan.